welcome to online lectures with Pharmaternity the Schoolboy. Today we'll take a look at pharmaceutical calculations, and the topic is density, specific gravity, and specific volume. There's a question on the board, a question based on this topic. The source of the question is Pharmaceutical Dispensing 1000 Objective Questions with Answers by Vincent C. Okore. So I decided not to include the objective answers. My focus is on the question. Now let's look at this question. That should be question 283 from this book. Which edition is this? 2001. All right, let's go. Solution. Before you can answer this question, you need to know what specific gravity is. You also need to understand concentration. We have molarity. Molar concentration. We have molality, molar concentration. Okay, so we also need to understand the relationship between concentration and the molar mass, and at the same time understand the relationship between specific gravity, the weight of substance, and the volume. Now, the first thing we need to do is to look at this what these things mean. This thing mean 40% weight in volume solution of dextrose. By convention, generally 40% weight in volume means 40 grams of dextrose in 100 ml solution. 40 grams of dextrose in 100 ml solution. That's the meaning of 40% weight in volume of solution of dextrose. Now, so 40% of dextrose solution means 40 grams of dextrose in what? 100 ml solution. This is just a solution because it's in liquid form. We don't know the exact volume of the solvent in which this 40 grams was dissolved. So that will lead us to using the specific gravity of this solution to convert this entire 100 ml of the solution back to the weight. So even though this is just the 40 grams, this doesn't show the total volume, but we want to use it first. We move this 100 ml to remove this 100 ml, we move it to what? Weight. So we know what gram of dextrose is dissolved in a particular weight of the solvent. That's our mission. So we have 40 grams of dextrose in 100 ml solution. So let's move this 100 ml solution to weight. What is specific gravity? Specific gravity of a substance is the weight of that substance. The ratio of the weight of the substance to the weight of equal volume of a particular standard, which can be water or hydrogen dependent. If the substance is a liquid or if the substance is a solid or a liquid, the standard used is water. But if the substance is a gas, the standard used is hydrogen. But here, this is solution, which is liquid. So the standard here to be used here is water. So we now defined the specific gravity of dextrose solution as the weight of dextrose, ratio of the weight of dextrose to the weight of equal volume of water. By weight of equal volume of water, I mean the weight of water that has the same volume with dextrose. So the volume of dextrose is 100 ml. So what is weight of that water that has the same volume as dextrose. So if the volume of dextrose is 100 ml, that means the volume of water is also what? 100 ml. Because it says weight of equal volume of water means weight of water that has the same volume as dextrose solution. So the volume of that water is what? 100 ml. So if the volume of water is 100 ml, what is weight of that water? So if the volume of water is 100 ml, remember that for water, 100 ml of water is set as 1 gram of water. For water, 1 gram is set as what? 1 ml. So if the volume of the water now is 100 ml, by the virtue of the fact that the volume of dextrose is 100 ml, that means 100 ml of water will now give us what? 100 gram of water. That's the meaning. That's the meaning. So 1 gram of water is 1 ml of water. Therefore, 100 ml of water will give us 100 gram of water. So, if that is the case, we now find out the weight of this dextrose solution. Specific gravity of dextrose is equal to weight of dextrose over weight of equal volume of water. We've calculated weight of equal volume of water to be 100 gram. So this is what? 100 gram. Weight of that dextrose solution. This is solution, so not solid one. This is solution. Weight of the dextrose solution, we don't know, we call it W. Specific gravity of dextrose solution, we are giving as what? 1.23. So 1.23 is equal to weight of the dextrose solution over 100 gram, which is weight of equal volume of water. We make this W the subject of the formula. W is now equal to what? 1.23 times 100 gram, which is 123 gram. So 123 gram is now the weight of the dextrose solution. 123 gram is now the weight of the dextrose solution. So if that is the case, we now go back to the question. Let's go back to this place. So here now, 40 gram of dextrose in 100 ml solution. This also implies that 40 gram of what? Dextrose is found in what? 1 to 3 gram of the what? Solution. We move this 100 ml to what? Weight. We have moved the 100 ml to the weight of the what? Solution, because we want to find out the actual weight of the solvent in which the dextrose was dissolved. So if the solution is 123 gram and the dextrose is 40 gram, remember that solution is equal to solute plus solvent. Weight of the solution is 123 grams. So 123 grams is equal to weight of the solute is 40 grams plus what? Weight of the what? Solvent, which you don't know, WS. So we make the weight of the subject, weight of the solvent, the subject of the formula. So we make the weight of the solvent the subject of the formula. So if you make the weight of the solvent the subject of the formula, so WS is now equal to what? 123 gram minus 40 gram, which is what? 83 gram. So the weight of the solvent, in this case is water anyway, in which the 40 gram of dextrose was dissolved to get the solution is 83 gram. So we've gotten the weight of the solvent, which is water, to be a 3 gram. Now let's go back to the question again. We were given the molar mass of what? Base. Remember, we are told to find the molar concentration. We are going there. So we are given the molar mass of dextrose to be what? 198.2 gram per mole. What is molar mass? What is the relationship between molar mass, the reacting mass or the mass itself, and the number of moles? Number of moles M is equal to reacting mass over what? Molar mass. So, number of moles is reacting mass over molar mass. Why are we going to this number of moles? Look at the reason. What is molar concentration? Molar concentration, molar. We have molar, molar. From here we get molarity. Something like that. So molar. So we are told to find what? The molar concentration. They are all concentrations. But this one, specifically the number of moles, has to do with the number of moles in the volume of the solvent need to be in 1 kilogram of the solvent. It must be specifically 1 kilogram of the solvent. The solvent must be 1 kilogram. This is something of all the long story. The solvent must be 1 kilogram. In 1 kilogram of the solvent. But this one, there's no specified amount of the solvent. This one must be in 1 kilogram of the solvent. So that's our target. The number of moles in 1 kilogram of the solvent. So the number of moles is what leads us to this number of moles. We want to use this weight, this weight, and find it divided by the molar mass, its molar mass, to get the number of moles of the what? Of the dextrose. So let's go. Number of moles is reacting mass over molar mass. The mass here is what? 40 grams over what? Molar mass. Molar mass is what? 198.2 grams per mole. This is the molar mass. So the number of moles is 40 grams divided by 192.8 grams per mole. So I can clean here now. So if that is the case, we are getting to somewhere. If that is the case, excuse me. Sorry, I will use this for calculator so we don't waste time. So if that is the case, we punch our calculator to get this. If we divide this, we have something like this. 40 divided by 198.2. So number of moles of this dextrose is now equal to 0.202 moles. 0.202 moles. So we have moved this, remember, from the solvent. Solution was formed by solute dissolving in solvent. So this solution was formed by dissolving 40 grams of dextrose in 83 grams of water to form this solution. This is number of moles. We have moved. Let me repeat what I said. That this solution was formed by dissolving 40 grams. Where is it again? Here. By dissolving 40, we have gotten this to be what? Okay, let me write it out here. 40 grams of dextrose plus 3 grams of water give us 123 grams of dextrose solution. This is what happened. All this I've been solving. This is what happened. That 40 grams of water of dextrose was dissolved in 83 grams of water to give us 123 grams of dextrose solution. But we have used the molar mass of dextrose to move the amount of this dextrose itself to 0.02 moles. Therefore, remember what we are told to find: the molar concentration in 1 kilogram. 40, moving this to what is it called? To moving this to number of moles. We have that 0.20 moles of dextrose was dissolved in 83 grams of what? Water. That's what happened. We have told to find how many moles of this will be in 1 kilogram of water. The solvent. Remember what I said, that this has to do with in 1 kilogram of the solvent. How many of this will be in 1 kilogram of the solvent? We don't know. This and this are weight, but they should be in the same units. So we'll move this thing to gram. There are 1,000 grams in 1 kilogram. So we replace this 1 kilogram with 1,000 grams. 1,000 grams make 1 what? Kilogram. So anywhere we see kilogram, we put 1,000 grams. So here we'll do it again: 0.2 moles of dextrose in 83 grams of what? Water. How many moles of dextrose will be in 1,000 grams of water? We don't know, we call it X. So X is now equal to what? 0.20 moles times 1,000 grams. We are cross multiplying, divided by what? 83 grams. Gram will cancel gram. So let's punch our calculator again. 0.202 times 1,000 equals 202 divided by 83. So the answer is what? 2.43. 2.43. The molar concentration of this is what? 2.43 moles per what? Kilogram. Moles per kilogram. This is the molar concentration. 2.43 moles per kilogram. This is the molar concentration of this solution. 2.43. Please, no difference between this and this. This must be in kilogram. This can be in mil, DMQ, what have you. But this also has business with what? Of course, you must move it to the what? Using the what? Depending on the nature of the question, move it to the what? Number of moles using the what? The molar mass. So the answer is what? 2.43 mole per kilogram. Thank you very much for your attention. Please, if you have any question, feel free to chat me up. Chat me for your question, drop your question using the WhatsApp link. Using the WhatsApp number on the screen. Please, my YouTube channel and Facebook channel are on the screen. Please subscribe to my YouTube channel for more lectures like this. Also, follow me on Facebook. The name is For Maternity, the Schoolboy TV. And God will bless you as you do so. Please share with your friends, your colleagues, your children, your students. Someone out there may be in need of these lectures. Once again, thank you for your attention. See you next time. God bless you.